Hello, everyone. Welcome to today's webinar, What is a Gateway in the SCADA World? My name is Beth Capellas, and I'm the Marketing Manager here at Triangle MicroWorks. Before we get started, I'd like to go over some housekeeping items and some introductions. The webinar is scheduled to be 1 hour long. We will be stopping for questions a couple of times throughout the webinar, and we'll stay on afterwards to answer as many questions as possible. Please submit your questions as soon as you have them. Don't feel that you have to wait until break or until the end. You can submit them online using the webinar menu under the section titled Questions. We have a team of experts ready to answer questions and will respond directly to you, not the entire audience. So to be clear, the questions are not seen by the entire audience. They will only be seen by the folks answering the questions. We will stop a couple of times throughout the webinar to read and answer questions. And as I mentioned, we will stay on afterwards for as many questions as possible. Next, I'd like to introduce our main speaker, Matt Green. Matt is a senior applications engineer here at Triangle MicroWorks. He's been with us for about 6 years, and he specializes in QA testing with all of our simulation tools in Gateway. Matt is also one of our lead product trainers and presenters for webinars and customer demos. Before we get started with today's topic, I'd like to just give a quick overview of Triangle MicroWorks. We were established in 1994 and are headquartered in Raleigh, North Carolina. We have customers in over 70 countries and work mostly with equipment manufacturers, electric utilities, and system integrators. The products that we offer all support the standard SCADA protocols and fall into 3 categories. First category is source code libraries. We license source code directly to manufacturers for use in their devices and systems. This allows for a much faster time to market and greatly reduces their costs and their development time. We also provide testing tools supporting these libraries and protocols. These tools are used for communication testing in the lab or the field. They are designed to troubleshoot, simulate, and automate testing. Lastly, we also provide a SCADA Data Gateway, supported on both Linux and Windows, for protocol translation and data concentration with all the standard protocols, as well as OPC. The Gateway is one of the main tools that you will be seeing here today. So now that you know a little bit more about Triangle, I'd like to go ahead and hand it over to Matt to kick off the topic we're here to learn more about.
Thanks, Beth. So we're going to start out today talking a little bit about what a gateway is and what it isn't. Most of you have probably heard of routers before, so we're going to make a kind of comparison to start there. So how is a gateway different than a router? A gateway is a single point of access to computers outside of your network. You can think of it like a door, while a router determines the shortest possible path data can travel from computer A to computer B. This is like a hallway or a staircase. Gateways also have other functionality that a standard router would not, and the next slide's on that functionality. So gateways tend to have these functionalities. They can work as a data concentrator, they can work as a protocol conversion, a local HMI or alarms, a historian, or have security features for both users and data. Data concentration is used when you want to gather data from multiple sources and combine them into one database for a top-level SCADA device or HMI. This allows you to see all of the important bits of information at a glance from a single location. Protocol conversion or protocol translation is used when you have a system that needs to communicate across multiple protocols. This is commonly used when a substation is communicating with one protocol, but the transmission may use a different protocol. Another common usage of this is when a system is being modernized or upgraded to newer technology, but legacy hardware is still required during normal operation. Gateways can also act as a local HMI if it has a display available for in-substation usage. This display provides information on the health and status of the system and to provide alarms or events for conditions that may or may not be monitored within the control center. The historian functionality can be used to store and log all of the data in a system. This allows for review of historical data, which is especially helpful during testing or during catastrophic events. Some historians even have a reporting capability. Security features are also included in many gateways. This includes data-specific security, such as secure authentication, or user-based protection, like role-based access control. So let's take a look at a very simple system. This is our simple data concentrator system. In this situation, we have several DNP outstations in our downstream substation, and we also have a DNP control station upstream. In this situation, what we're going to do is we're going to gather some or all the data points inside of these DNP outstations, and we're going to combine them into a single gateway database. This database is then exposed up to the control system, so that way the DNP control station can actually see all the variables and data stored within all the outstations beneath. So how exactly does this happen? Well, gateways typically have multiple network adapters so they can access multiple different networks. For each of the connections to a outstation or server, you'll need to have an internal server database or internal master database. And then for each control station or master connection, you'll need to have an internal database as well for like a outstation or server. After that, you can use the mapping logic here in the middle to map the points that you're interested in from the masters to the database. Once that happens, your database will be filled with the information from the external devices and available for your control station. So this is a real-world example that we deal with frequently. We have a few customers who have big wind farms, and on these wind farms, they have multiple windmills. This can be in up to hundreds of windmills. And each of these windmills is a replicate of each other and are performing the same operation. Because of this, the devices that are monitoring this are all storing the data in a very similar manner. So it's very easy for you to be able to combine and grab the information out of that, combine it into a gateway, and then that gateway can then push that information up to a historian, an alarm viewer, or the control station. These type of systems could easily have more than 200,000 points. So now let's take a look at our simple data concentrator example again. But this time, instead of having 3 DNP devices, we have a Modbus device in the system, down here. A second gateway is added in between the Modbus device and the data concentrator. This one acts as a data converter and provides the DNP3 interface to a legacy Modbus device. Some gateways can actually perform both of these functions at the same time, and you wouldn't actually need this second gateway as a protocol converter. If your upstream control center is using a different protocol than the local substation, some gateways can act as both a data concentrator and a converter at the same time. This allows for the important bits of your substation to be sent up to the control center. In this specific situation, we have a DNP3 outstation, a 61850 server, and a 104 controlled station, all being mapped, translated to an ICCP database within the gateway, and then that is exposed up to the ICCP control center. So one thing we haven't talked about yet is controls. So controls kind of go in the opposite direction of what we've been talking about today. In this situation, the control center will send the control down to the gateway, and it's expected that the gateway can then map that control to its respective master and send that control down to the outstation that needs to receive it. Controls that are sent from the control station can happen automatically with a direct operate, such as reconfiguring a parameter in a device, but higher risk controls, such as opening a breaker, may require a select before operating the point. This is just an extra security step that we put in between the operate. It essentially allows the device to know, I'm going to be performing this higher risk control, and then you have a certain time to actually issue that control. That way someone doesn't misclick something or send the wrong control by accident from the control station. Controls do need to be mapped to similar controls and other protocols when working as a data converter. So now let's talk a little bit about the data and its layout itself. Configuring a gateway does require knowledge of the SCADA protocols you'll be working with. Protocols can fall into two different categories. We've got point index or tag-based protocols or model-based. So index or tag-based protocols, this is how it's kind of set up. A point is a uniquely identifiable physical or logical entity addressed by an index or a tag. It contains a value for inputs like analogs, binaries, or counters, or outputs like analogs and binaries. Protocols that support index or tag-based points are DNP3, 6870.101 and 104, Modbus and OPC. Model-based protocol is a little bit different. The semantic model provides paths based on standardized names for objects and attributes that allows for the system to communicate not only the values of the data, but also the meaning of the data and the relationships between various other data points. Because of these protocol standardizations, you can quickly recognize data and its meaning across devices and systems. Protocols that support model structures are IEC 6870-6, otherwise known as TASI2 or ICCP, and IEC 61850. Now, one thing we haven't talked about, which also is very important, is quality and time. That's what these next two slides are going to be going over. So let's start with quality. Both model and index or tag-based protocols provide a quality indicator with static or event data. These quality indicators give the user the status of the data being received. Some quality indicators are valid or invalid, communications lost, or bad data, or even that the data you're receiving is in test. Typically, index protocols provide the quality as a flag within the point received, while models provide it as a separate point in the same grouping you're receiving. When mapping quality between different protocols, some details might be lost because qualities are not standardized between protocols. Timestamps are a little different. Timestamps are only included with event data, and these timestamps give a user an understanding of when the events occurred, and maybe more importantly, the order in which they occurred. Both model and index-based protocols have separate timestamp attributes that are provided with event data. Different protocols have different requirements on timestamps, and accurately converting between the two is part of the gateway's job. Gateways should propagate the received timestamps if available, but one exception to this could be, think of a situation where you have a Modbus device and that information is being converted to DNP. Modbus doesn't have a concept of timestamps with its point, so the best the gateway can do in this situation is fill the time space slot when reporting up to the DNP with the time that it received the data from the Modbus device rather than the timestamp from the Modbus device, which wasn't available. So now let's talk about data transfer. We have grouped different methods of data transfers into 3 different groups. While these methods may not be 100% identical protocol to protocol, we can draw some comparisons between them. Polling or reading is when a client requests the current state of data. This can be done either once or periodically, and reads are performed on an entire database, generally after the device has been restarted or there's been a loss of communication, to make sure that you can just quickly get back on track and make sure that the client or master's database is up to date again. This method requires the most bandwidth of your system to keep data accurate due to the large data that's being transferred. Event polling, or report by exception, is when the client or master requests only the data that's changed since the last poll, instead of all the data that it already has. This can be done once or periodically as well. This requires less bandwidth of your system to keep data accurate because of the smaller set of data that is being transferred. The last one we'll be looking at today is unsolicited messaging, reporting, and subscribing. This is when the client or master requests that the server sends changes as they happen and not wait for any sort of polling period. These can generally be enabled or disabled. This is the fastest and most effective way to keep your client or master's database accurate while limiting bandwidth. I'm going to stop here now and pass the mic back over to Beth and see if we have any questions that should be answered before moving on to the live demo.
We did actually get several questions that came in. So let me go ahead and read off some of those. Which protocols are typically used in a substation environment?
So we've mentioned a few of them so far, but you're likely to see things like 61850, DNP3, Modbus in some of the older systems. Generally, there can be a mix of protocols as well, like we've kind of described a little bit. There's 101 and 104 as well, and TASI2 and ICCP are kind of the ones that we've pointed out today and talked about.
Mm-hmm.
Oh, and don't let me forget OPC. We've got OPC, OPC UA, Classic, Alarms and Events, all the different flavors of OPC.
Okay, next question. How does a gateway deal with a system disturbance event like a trip?
So generally when a lot of events are all happening at the same time, there's a lot of buffering that goes on. You don't want to overload the bandwidth and have packets get lost or things along those lines. So it'll generally buffer up all of these events and send them out when necessary and when things cool down a little bit. So if a lot of events are all happening at the same time, you want to look into like 6150 supports buffered report control blocks.
Okay, next question. Who writes the mapping logic?
So I assume that's referring back to one of the slides I had earlier with the mapping logic. The gateways generally contain that themselves. Like our SCADA Data Gateway, we have engineers who work on the best, most efficient way to map from protocol to protocol. Because everything between protocols like quality and controls aren't 100% standardized, there is some trying to find what's the comparable thing in between the two. So our engineers write that up for our gateway. I'm sure other gateways works in a similar manner.
Mm-hmm.
It's not something the user, is expected to do live.
Okay, next question. Does your gateway support two-way controls between two control centers? One supports ICCP and another OPC.
So I'll open that up to our experts. I would start with saying yes, but I want to make sure that I'm not misunderstanding the question a little bit. We support controls from multiple different locations, but I want to make sure that I am understanding the question properly.
And they have answered it actually. You are correct. Yes, it supports mapping OPC protocol to ICCP protocol.
Okay.
Okay. So in our next question, do all gateways support all the functionality?
So I can't speak for all gateways, but I know that a lot of the gateways have these kind of built-in functionalities for them. For example, obviously our SCADA Data Gateway can do protocol mapping, it can do protocol translation, data concentrating. So I can't say that every gateway contains all of these functionalities. So you'll need to look in when considering which gateway you want for your system. But some of them are more common than others, and you just kind of have to figure out which functionality the one you're interested in purchasing contains and if that will meet your needs.
Okay. Next question. Can proprietary protocols be mapped, for example, to DNP?
We don't typically support that as far as I know. Generally, you can kind of route that type of thing through. I think OPC is a potential way that you can kind of do that. But if we have a better answer from one of our engineers, feel free to fill in some information there.
That's consistent with how they answered online.
Okay.
Okay. Do I have to map qualities?
Well, half is a strong word. You don't have to map qualities, but if you don't have the quality of the data that you're getting, you have no idea kind of what you're looking at. If you're getting quality that is considered bad, maybe something's gone wrong with your device and you think a breaker's open when it's closed or vice versa, you can have all sorts of logic that's based off of that bad data that's going to have really bad things happen in your system. So do you have to know? Should you? Absolutely. It's without that, you have no idea the data you're dealing with has any meaning whatsoever.
Okay, next question, and this might be a good one for the panel. How do we secure a SCADA Data Gateway? So I can open that up to the panel, or it was answered online. I could also read the answer. So typically using TLS and MMS certificate-based security.
Yeah, and I would also say that later on in the presentation, I will be going over some of the security features that's built in with our specific gateway. I did touch on a little earlier that there are user access control that we have built in and that other gateways also do. And then there are also things like secure authentication and TLS and things like you were reading off there.
Mm-hmm. Okay, and I think I'm going to do one more question, and then we probably should wrap back to the presentation and the demos. This is a little bit of a broader question. How do you test a gateway?
Yeah, absolutely. So I think we actually did a whole webinar on how we test our gateway. We have a tool that's set up to allow you to test basically all the inputs and outputs. That's effectively what you want to do. You want to isolate your gateway in a situation and simulate or stimulate all of the inputs to your gateway, and then you can verify the outputs from your gateway, whether that's connecting it up to your actual control center and verifying on screen that you're getting the data that you expected, or you can do something like we did during our webinar when we did do this, where we had everything built into our simulator tool, both all of the downstream devices and the upstream devices. And we kind of had this constant loop going on where we would change a point, verify that it changed in the control center, and then repeat that process as all points are changed. But effectively, you just want to isolate it, simulate the inputs, verify the outputs. Are there any more questions, or should we move back to the presentation?
Sorry, I was on mute that whole time. We do have a number of questions still continuing to come in, but I would suggest going back to the presentation at this point. Our panel experts are working online to answer those questions, so keep them coming, and then we can loop back at the next break to answer some more of those questions on, live on the webinar.
Okay, yeah, that sounds good. We have a few more Q&A sections we'll stop at too, so we'll have plenty of time. Okay, so we're going to move over into kind of the live demonstration of our specific SCADA Data Gateway. We're going to build up the first workspace that we're going to be looking at, the first configuration of the gateway, and show exactly how that's done. I have a few diagrams to show exactly what we're going to be building ahead of time, and then we can go through and actually build that up. So I will jump back over here. So this is the first example we're going to build up, and this is going to be with polling. We're going to have a control center of a DNP3 master, and our downstream device is going to be this Modbus server. So inside of the gateway, what we're going to need to build is we're going to need to build a Modbus client in order to connect up to this server. We're going to have to execute polling in order to pull the values across, and we're going to do that at every 15 seconds. We'll hopefully see a response about every 15 seconds. From there, we'll have the information inside of our client. What we'll need then is a DNP3 outstation database that our control center can interact with. So we'll go ahead and generate that database. Then we'll need to create the mapping from our Modbus client into our outstation database. And from there, our control center will actually be able to get the values across. So let's take a look at how we'll do that. And in order to do that, I need to introduce the two applications I'll be working on today. The first application that I'll be working on today is our DTM tool. So I'll just pull this over real fast. So our DTM tool is our distributive test manager tool. It is our system simulator we use for load tests, protection tests. It is generally our server simulator tool, but it can simulate both clients, masters, servers, outstations, anything along those lines. In this situation, as mentioned in one of the questions, I'm actually going to be simulating both the IEDs, or the downstream devices, and the SCADA, or the control center. So based on that diagram we looked at right now, I have my DNP3 controls station, and I have my server Modbus device. So that's what I'm going to be doing for all the demos that we're going to be looking at today. So I'm going to move this back off the screen, and I'll put Gateway in the middle. So this is our SCADA Data Gateway tool. This is actually a web client for our SCADA Data Gateway tool. I'm not actually running the SCADA Data Gateway on my laptop right now. It's actually off running on a Linux machine right now. And since we're going to be looking at 4 different examples, I actually have 4 different web clients up here. Each of these web clients is connected to a different SCADA Data Gateway, and they're all running on Linux. That being said, we do support Windows as well. So let's take a look at the GUI a little bit here, since that's what I'm going to be interfacing with. On the left, we kind of have this workspace view. This is where we're going to be adding databases and our controls, our polling, our event polls, our reports, things along those lines. Everything will be created and added on this left side here. And on the middle area, you're going to be able to see kind of the details of what's going on whatever you have clicked and selected. So let's go ahead and get started. The first thing we want to do is we want to get my Modbus server's data into the SCADA Data Gateway. So to do that, we're going to need to create a master Modbus. So you just right click here, and then we'll do an add TCP channel master. So from here, you're going to pop up a configuration window. And while I know most of this stuff fairly well, people looking at Gateway for the first time may not. So we actually have a built-in function here, this little help. And if you click this, it'll actually give you a pop-out here on a description on what each of the configuration options we're setting up here will actually do. I'm not going to leave these up, but it is important to know that if you're working with the Gateway for the first time, or maybe a new protocol you're not necessarily familiar with, you can get some quick information just like that. So now let's go ahead and fill out the configuration. The first thing I'm going to do is I'm going to select a Modbus master, and then I'm going to give it its IP address. So I know that my server is being hosted on DTM, which is on a totally different computer. So I'm going to give it that IP address here. The next thing I'm going to do, and I could leave it at the local IP address at 0.0.0.0, but what I'm going to do is I'm going to go ahead and give it its local IP address as well. So I'll get 192.168.1.50. You'll also notice that we have a port number here at 502. That's the standard default port for Modbus. We try to fill in the defaults whenever possible to allow configuration as simple as possible. But we know that you may be on a test environment. You may just be working with Gateway for the first time, and you want to play around with this. So you can change the port number, but when at all possible, you want to try to leave the port number to be what the protocol expects. And then from here, all we have to do is give it a name. Name it Master Modbus. Hit OK. The second thing that's going to pop up is going to be configuration options specific to the protocol you chose. Since I picked a Modbus device, it's going to give me a little bit more information and configuration here. Again, you could always click this question mark to get more information on it. In DTM, I set up the configuration just as everything default, so I actually don't have to change any of this. So I'll hit OK. And then the last thing that's going to pop up is we need to give this master a database. Right now, we've got the protocol up and running. It's already connected up to DTM, so everything's happy there, but it doesn't have any access to any data yet. For Modbus, there are 4 different types of data. We've got coil, discrete input registers, and holding registers. In this situation, I'm just going to go ahead and add a coil, but I will show you how to add more data types later. So I'll just hit OK. And so what you'll see over in the workspace area now is we have added this master Modbus, and you can see the protocol there in case you just didn't name it that. You can name it whatever you want. we've got this L1, and then we've got the T0, which is the coil data type. So if we want to add more data types into this master Modbus, you just go to L1, and you right click, and you can say add data type. From here, you've got this window again. You can select the other data type that you want to add. I can do an input register and hit OK. So if I go into this coil, this T0 coil, you'll see that there's actually no data in here yet. And that is because I haven't added the points that I'm interested in. So to do that, you just, like we did before on L1, you go to the T0, you right click, and you say add MDO. Now let's talk about MDOs and SDOs a little bit. An MDO stands for a master data object, and this is just a data point that your gateway is going to have inside of it when you configure it. So when I add this MDO, I will then have access to the data inside of my Modbus server. An SDO is a server data object, and it's exactly the same idea. That's the database inside of your gateway that is going to be exposed up to your control center or whatever your upstream device is. The MDO and SDOs can be related, and that's how we do our mapping, and I will be showing you that soon. So I'm going to go ahead and add this MDO. So we've got this information object addressing. That's just the index or tag that we were talking about on the previous slides. So for default, it just went ahead and put 1 in here. You can actually name this or add a description or change the options of this different object, but I'm just going to go ahead and hit OK and pull over this index 1 coil. So what we'll see is we've got a name here. It's the master Modbus. That's the device it's in. We've got L1, and then we've got T0, which is the coil, and P1, that's the index. And you also see that that value is off. Now, if I go over to DTM and I change that value, you actually won't see it update here automatically. And that's because we haven't told it how to transfer data yet. So let's talk about how you can get these different data transfer types that we talked about in the previous slide. So you go back to L1, and this time I'll click on it, and we'll see all the information inside of the L1. In this situation, we have a bunch of action masks. This is essentially what is the gateway going to do. So let's just click this little pencil icon here to edit it. And you'll see a bunch of stuff filled out here. For a Modbus, you can essentially perform these reads or pulls like we were talking about before. We've got the coils, the holding registers, discrete, input registers, everything along those lines are here. You can click this drop down because so far it's configured not to do anything. You can click this drop down. You can say you want to read all the points, or you can read a range. So you could do something like starting index of 0, ending index of, say, 2. At the very bottom here, you'll see that there is a Modbus section action period. And what that means is this is how frequently we're going to be doing this. Generally, with polling, you're gathering a large set of data, even if it is the data that you already have within your database, and that can take up a lot of bandwidth. So generally, your polling rates are going to be kind of slow. I've seen them as much as once an hour type thing, where it reads everything once an hour, and it relies on other data methods in order to get data more quickly, but use up less bandwidth. For this demo, because I don't want to sit around for an hour waiting for this, I'm just going to set it to 15 seconds and then hit OK. So now when I go back to my coil, my data type is still in here. And what we'll see is if I go ahead and change the data in my DTM, after kind of that 15-second polling period, we should see the value inside of our gateway update. So we'll just give it a little bit more time. And sure enough, it did. So now I'm able to change the value inside of my Modbus server, and we'll have that information inside of the gateway. Now, it doesn't have to be simulated like we're doing in DTM. This could actually be a physical device, a simulated device, anything along those lines, as long as it's communicating across this Modbus protocol. So now we have access to roughly 15 seconds of difference there, real-time information. How do we get this into the database that our control center, which is DNP3, is going to be able to monitor? Well, we're going to follow the same process. We're going to right-click here, and then we're going to add a TCP channel. We're going to choose this outstation. Again, it's going to look very similar. You're going to click this drop-down, and we're going to select a DNP3 outstation. Following the same logic, I'm going to tell it where its control station is going to be. And I'm going to give it its own IP address as well. And I'll name this outstation, DNP3 outstation. And hit OK. You will see this looks a little bit different, and that's because we have chose a DNP3 device this time rather than a Modbus. That being said, we still filled it with the defaults, and since my control center is also using the defaults, I don't have to swap anything here. So I'll just hit OK. And following the same logic as before, we need to give it a data type. These are obviously going to be different as well because we are in DNP3, but the comparable data type to the coil would be your binary input. So I'll hit OK. So now we have a device created here, and we've got our binary inputs. So mapping is actually relatively simple. You just go to the point that you'd like to map, and you just drag and drop it from the coil T0 to the binary input T1. At that point, you'll get a pop-up. It's going to tell you exactly where you're going to put it. To keep things the same, I'm actually going to change my indexing to 1. So that way, 0.1 inside my Modbus is 0.1 inside of my my DNP database. This could be however you want to organize it. It doesn't necessarily have to be this way. So if your downstream devices don't exactly line up with your control center, you can wire this however you want. But for me, it makes most logical sense just to keep these indexes the same. So if I hit OK here, what you'll see now is I now have a DNP3 outstation point. It is a T1 P1, which T1 is just a binary input. You can even see right next to it that we are mapping it from the Modbus master from its T0 P1. If I happen to make a mistake today and this wasn't the point that I wanted to map, or I needed to remove a mapping or something along those lines, you can always click this button here and it will delete any sort of mapping and allow you to start back over. So that's kind of the first demo I wanted to show off today, and actually build up a workspace from scratch. The next few demos that we're going to look at, I've already built up the workspace, so we don't just have to sit through me creating a bunch of devices kind of on the flow. So let's jump back over to our PowerPoint for a second, and let's take it the next situation we're going to look at. So this is the next system we're going to take a look at. We have our controlling station as a 104 device, and then we've got our simulated DNP3 outstation, again in DTM, as our IEDs in the network. This time we're going to be using event polling, so I can show you how to configure that. And because event polling is going to have much less data in it, we can actually decrease that polling period to only every 5 seconds rather than the 15 seconds we're looking at. And then after that, you'll be getting your responses as the events are changing, as data is changing. That mapping will move over, and then we'll have our responses up to our control station. So again, we'll have this mapping here, and we'll need to have a DNP3 master and a 104 database. So let's take a look at that. So this is the next example we'll be looking at. So I have, let's see, this master here, this DNP3 master. And what you'll see here is because I was able to pre-make this workspace, I actually have a few more different data types. And if you click inside, you'll see I actually have 5 points being mapped instead of just that 1. And this was actually really easy to do. You can map multiple points all at once by dragging and dropping. You could drag and drop them individually, but you can also multi-select. And once you have these multi-select, you can drag the whole group and drop them. Then it's going to give you this kind of configuration window. So it's going to take all the points that you drag and dropped, and it's going to go ahead and fill out a text box here with all the addresses you're mapping this to. Again, this is fully editable, so you can actually go in and change these numbers however you want. But this is how I was able to map over, 5, 10 points at once. If you happen to have, hundreds or even thousands of points you want to map at once, I wouldn't recommend doing it this way, as it still could be a long process. But we do have exportable configuration options in our SCADA Data Gateway. And what that'll allow you to do is take like a CSV file or something over to Excel, use the built-in functions in Excel to change that CSV file, upload it back into our SCADA Data Gateway, and then all of those mapping points will have been done automatically. So now let's take a look at how we're getting this data across. So I'll go to this L4 here, and we'll take a look again at the action mask. So in this situation, I've got a little drop down, and you can see we're reading class 1, class 2, and class 3 change events. This is effectively doing the event monitoring and polling for events rather than just polling for everything during a set time. And again, this is done at 5-second period rather than on the 15-second we were looking at before. So that's how you can kind of do event mapping. And again, I could go in and change the values and they would swap out through our system and go back up to my control center. The next demo we're going to look at is reporting. And this is going to be a little bit different because we're going to be looking at 61850. So let me pull up my diagram. In this situation, we're going to have a 61850 client inside of our gateway. This client has already enabled reports, which I'll show you how to do. And what that'll do is allow this server to automatically, anytime the values change, send a report up to our 61850 client. That value is then going to be mapped to a DNP3 outstation database, which is going to be accessible by our DNP3 controllable station. So I'll show you how that is set up. Third one here. So effectively what we have here is a 61850 is our first model-based protocol that we've been looking at. So to show off what that looks like, I'm going to pull back over DTM for a second and show it off. So in this situation, we have a bay controller device, and inside of it, it has several different logical nodes. These logical nodes are the grouping we were talking about before. If I open up this XCBR, which I know is a breaker, we'll have several different data objects inside of it, but the one we're going to be looking at today is the position object. So this is the position or state of the breaker. So we have on, we have off, we have intermediate, and we have bad. We also have the quality and time associated with this position and any other attributes that may relate to this. So as you can tell, this is not a flat table view, kind of like what we've been looking at today. So this data is actually all stored together in what 61850 calls data sets. And what a data set is it's a group of data that you find important, the stuff that you want to be sent up via reporting. Some values can be read just like other protocols, but if there's a value that you're interested in, you put that into a data set, and then you put that data set into what's called a report control block. And when you enable reporting, you enable the report control block, all that data is packaged together and sent up as part of the report. So let's look at how we do that in our SCADA Data Gateway. So I've got our 61850 client here, and what I'm going to do is add a report control block. So I just right click here, and then we just simply have add 61850 report control block. When you add these, it automatically enables those reportings on your server. So it goes ahead and sets up the ability for it to auto send those messages. And we've done that with 2 of them so far. We've got our statuses, and that's going to contain the position that we were talking about before. And as you can see, it was off like it was in DTM. But it also has another bit of information in here. That is our CSWI, that's a controllable switch, and its position as well. But it's not just binaries, you can also do measurement values. So in this situation, we have a phase voltage and its magnitude is 874. I obviously can go into DTM and change that value. And what we'll see is that this value should come along a lot faster. We don't have to wait that 15 seconds or that 5 seconds for it to come across, because as soon as I changed it within DTM, it went ahead and published that or pushed that report out to our 61850 client. And of course, like before, that value is also carried over because of the mapping to our analog value here and reported up to the control system, the control station in my DTM as well. I did want to point out one other thing while we were looking at the gateway tool. When I'm inside of my DNP3 outstation, you'll see that it has a mapping and it's telling you where that value is coming from. What you may have noticed in other situations is if I went to our client, we're actually seeing multiple things. So this is saying that the arrow is kind of shifted the other way. This is saying that this XCBR position is mapped not only to the DNP point that I just showed off, but it's also being mapped to our OPC UA server. And that's something that if you're licensed for will happen automatically for you. So anytime you add any points any data to your SCADA Data Gateway, it's automatically going to be mapped over to this OPC UA server. And if I click on it, you'll actually see all of the data within it, all displayed out in kind of this table view. And this is really nice because that means if you bring up an OPC UA client and connect it up to your gateway, you should have access to all of the information inside of your gateway automatically without needing to configure it or do any CSV file INI changes, without needing to do any mapping. We'll just handle that all for you. So the last thing that we're going to take a look at today is controls. We talked about this a little bit on the previous slides. So let me show off what that looks like in the gateway. So this is what we're going to be creating. We have a controlling station. That's a 104. It's going to issue a control down to the gateway. It's the gateway's job to then get that control and send it out to a DNP3 outstation that's out there. So to do this, like we've done with mapping when the data was moving upstream, we're going to go ahead and put a 104 controlled station inside of the gateway's database, and then we're going to push that down to a DNP3 master. So in order to do that, we have this configuration set up. We have our DNP3 master, and we have our 104 database. So in this situation, we're going to take a look at controls. So I'm going to pull back over DTM and show off how that looks. So in this time, I'm not going to be dealing with the IEDs or the downstream devices and changing values inside their database to propagate the event. I'm actually going to issue a control from the controlling station. So to do that, you right-click on the master that you want to do, and you go ahead and do commands, and you can set up any of the commands that you would want to issue down. For this, we're doing an operation on a single point. So as mentioned, we do have the protection of the select before operate or the select before execute. But if this was something that wasn't so risky, say it wasn't a breaker position or something, we could just do the direct operate or the direct execute. But we have it configured to do the select before operate. And then we've got the index that we're going to be working on is 2006. So I'm going to go ahead and run these controls off in DTM and watch for the value to change within our gateway. So eventually what we want inside of our gateway is our DNP3 master to issue the same output or the same control as the one being sent from the SCADA system. So we'll monitor this point here and we'll see that it's at latch off. And if I send the latch on control, you'll see that that control came through instantly and was pushed back to my DTM downstream servers. So from this point, we're going to bounce back to the PowerPoint, and we're going to take another break for questions, as I'm sure the live demo has probably generated a few.
Mm-hmm. Yeah, we've got a lot of good questions coming in. So I'm going to try to focus on a couple that I'm seeing a lot of questions come in about adding points. So I think this one question will knock out a couple of those. Can we add points in the gateway database in bulk, for example, via a CSV file?
Yeah, so there's a few ways that you can add the data points into the gateway. One is we literally use a CSV file inside of our configuration. You can go into the back end of the gateway tool and export that CSV file. From there, you can just add a bunch of rows, add the points in, and then re-import that. And while you're there, you can also go ahead and automatically do the mapping. We do recommend maybe adding one or two of each point type first. That way you see the format that it should look like, maybe even do the mapping for one or 2 points first. And once you get that mapping done and it exported, you'll see how it will be laid out. You can then kind of mass produce effectively the lines using all the power that Excel has, re-import that, and you'll have all of those points ready and defined.
Great. Next question. Is there a way to create simulations in DTM such that you can specify a certain set of points to change state when choosing to run a simulation? For example, run a fault event which trips a breaker to lock out and cause a loss of voltage for every device downstream from the breaker.
Yeah, we actually have kind of a sample workspace that comes along when you install DTM that has some of these kind of more behavior approached simulations. What I'm showing off today in DTM, I'm trying to keep very simple as it's not, the thing that I have on the screen most of the time. But yeah, there is a whole scripting engine and default behaviors that we have included with some of our devices that allow you to do more complex simulations like that in DTM.
Okay. Next question, and Matt, feel free to hand any of these over to the panel. What is the maximum number of points that your gateway has been tested with?
So I don't know the exact number of the maximum number of points that our gateway has been tested with, and I may hand that part off later. But I will tell you, and we'll actually touch on this in the last few slides, that our gateway is a very powerful application, and it's really dependent on like the CPU and the RAM and just all the hardware specs where the gateway is installed on. Does anybody in our panel have any, hard numbers or recent load tests or anything that we've done?
So what I can do is read off the answer that we have here that has
Okay.
previously been answered by the panel. We have tested up to around 800,000 points. We typically have between 2,000 to 3,000 and 10,000 points in a single application. And we have production customers using around 100,000 points.
Okay. Well, it's
Okay.
good because I think I would have said closer to 400,000. So we were actually above the number I was going to give.
Mhm. Next question. How do we force a value in gateway?
So you can set up an internal MDO, and effectively what this is a master data object that isn't connected to a server or an outstation anywhere, and you can actually change that value inside the gateway GUI, like I've been showing you. And if that's mapped to anything, that value can go out as well.
Okay. Next question. Does OPC auto map points support control to another OPC server?
So we currently automatically add a OPC UA server, and those get automatically mapped. And correct me if I'm wrong, anybody on air, but you can also add an OPC client, and I think issue commands or controls from the client within the gateway.
Okay. Next question. Is it necessary to write the remote IP for a DMP3 outstation?
I was being very meticulous today when I was setting up the one workspace. I wanted to show what you could do, not necessarily what you have to do every single time. Obviously, you're going to need to have a TCP/IP if that's what you're using connection to your device. And if you have firewalls or subnet differences that are causing issues, you might need to go in there and change that. But you can easily leave that at like 0.0.0.0, like I was saying. That'll effectively just say, hey, gateway is running on this computer. If you can reach your partner, your client, your server on any of these adapters, just choose the one that works. So you don't have to, but I was trying to be very meticulous today just to show off what we can do, and have that kind of closed loop there.
Okay. Next question. Do you have any way to get a timestamp from Modbus?
So I think I mentioned this kind of offhandedly during one of the slides. Modbus doesn't innately have a timestamp that it sends across. So the most accurate thing you can do is use the timestamp that the gateway gets. So if the gateway gets a certain set of data at, say, a specific time, it'll put that timestamp, that time that the gateway receives the data, which isn't necessarily the time that the event occurred, as the timestamp, but it's the closest and best thing you can do with a protocol that doesn't necessarily support timestamping.
And I think this is a related question, but you might maybe have partially answered it. How is the timestamp assigned when transferring a data point from Modbus server to DMP outstation?
Yeah, I think that answer kind of answered it, but just real quickly one more time. The idea is Modbus doesn't send a timestamp, so you don't have access to a timestamp. So when the gateway receives the data, it says this is the closest thing I've got, and then when mapped over, it'll use that as the timestamp.
Okay. Next question. How are the ACK commands propagated back to the control station?
So when the controls are sent from the control station down to the gateway, it's going to try to propagate that immediately down to the server that it's mapped to. And when the server downstream has a response, that'll go back up to the gateway, and that'll get kind of mapped back into the database held within the gateway and sent back up to the control center.
Okay. Next question. Does the gateway support CID file imports for 62850 servers?
Yeah, we support ICDs, CIDs, SCDs, anything along those lines. We should be able to support and import into our gateway.
Okay, I think at that point, questions are still coming in, so they're continuing to be answered online. Let's go ahead. We only have a couple of minutes left. Make sure we get through everything else we need to get through, and then we can go back to questions.
Sounds good. So I'm going to resume. There are a few more features inside of our SCADA Data Gateway that we didn't go over in the demo. I kind of wanted to touch on those very quickly before we move on. The first is equations. So equations are a way that we can combine or modify data within the gateway based on mathematical or logical expressions. This can actually be really powerful because you can use data points gathered in the gateway databases that are from multiple different devices across your entire system to allow you to create points for a more complex application. So you can check, if this breaker's open and this breaker's open, then we have this type of situation. And these points can also be propagated up. The next thing that we can talk about is the channel indicators and our system health. So one thing I didn't look at is we have a few built-in views into the data into our SCADA Data Gateway. This view group pulls together all the important health warning data from across all the systems in your gateway to give you an overview of the entire health status of your system. And again, all of this data can be provided up to your control center for remote monitoring through the SCADA protocol. Someone asked earlier how we deal with security. This is one area of security we didn't talk too much about in the demo. We have the SCADA Data Gateway supports role-based access control with user management. And with user management, you can create different users with different roles, allowing each person to have different levels of access to the system. So in the screenshot below, we only have 2, but you can create plenty. The admin essentially can do whatever. It's a super user. Anything the gateway allows you to do, obviously the admin should be able to do. Whereas you may have someone who should just be a viewer. Their job is to make sure things are going well and alert someone if something poor is going on. So we have a just username, viewer user, just something random, and we have it as a role of users. And we have a bunch of built-in roles that you can set up and edit and add and things along those lines. And each of these, will have a password that they can use right off the bat to verify their own identity. It's also worth noting that today we've looked at very small systems. A lot of our diagrams have been 3 or 4 devices being concentrated up to a single control center. All of our demonstrations today have been one device to one device connection. It's worth noting that we have a flexible license here. You can use, tens or hundreds of points, kind of like what we've shown off today, or you could use up to hundreds of thousands of points, as we've answered in some of our Q&A questions. Again, just another kind of scalable thing. You can use 2 devices like we've done today, or even up to hundreds of devices that the gateway can support. We support this large range, and it's all really dependent on what the hardware that SCADA Data Gateway is installed on. And I think, as Beth mentioned a little bit earlier today, and maybe I have as well, our SCADA Data Gateway does run on both Linux and Windows platforms. So I think that answers all. I think that is the end of our slides here. I'm going to pass it back over to Beth for just some final thoughts, and then we'll get back into the Q&A.
Yeah, so we are at our hour, so I want to thank everyone for joining us today, and hopefully you've learned a little bit more about how gateways work and how our SCADA Data Gateway can support your needs. The webinar will be posted on our website if you'd like to watch a recording of that. It's published on our YouTube channel. You will get a survey after you sign off of the webinar today. If you answer that, I believe you responded with a link directly to the recording. You can download an evaluation license to the gateway directly from our website as well. And of course, if you have any questions, please email sales@trianglemicroworks.com.